Plan today. The first 3 sections of chapter 11. maybe 15 minutes for 11.1, 20 minutes 11.2, 20 minutes 11.3. Then tomorrow we're going to cover 11.4. So that's the plan for this week. Let's go to Pearson. 11.1. 11.1 is about the fundamental counting principle. I don't know if you already watched the video. In my video, I recommend you relate one example only whenever you think about fundamental counting principle. What example? The example I gave you in the video is this. So let's say you have a task, and your task is to go from A to C, passing through B. Yeah, let's say 3 cities. From A to B, we have 2 routes. From B to C, we have 3 different routes. Oops. So how many different routes do we have from A to C passing through B? And anyone tell me 5? Or does anyone have a different answer, different from 5? We have 2 routes from A to B. We have 3 different routes from B to C. Then how many different routes do we have from A to C passing through B? So the task has 2 parts. Part 1 is from A to B, 2 different routes. Part 2 is from B to C, 3 different routes. Then how many different ways that we can complete this task from A to C passing through B? By the way, the answer is not 5. If it's not 5, could anyone tell me what is the answer? Huh? Give it a try. Hello. So you haven't watched the video yet. So how about this? Let's try this one. If part 1 we choose the northbound, then we have 3 routes, right? 1, 2, 3. And if we choose to go the southbound from A to B, then we have another 3 ways. 1, 2, 3. So in total, how many different routes do we have from A to C passing through B? Did anyone have the same answer with me? Do you agree it's 6? Yes or no? Yeah. Thank you, Liam. Yeah, it is 6, okay? So this is a fundamental counting principle. I want you to remember this example whenever you need to think about fundamental counting principle. You need to remember this is a multiply. Please don't add them, okay? So if we have a task, if we need to complete a task, and the task has multiple steps or parts. In this example, we have 2 parts or 2 steps. If the first step has, let's say, m different ways to complete, and the second step has n different ways to complete, then we simply multiply the 2 numbers together, then we have the total number of ways to complete the whole task. That is the so-called fundamental counting principle. All right, so let's apply it. Don't rush. We will understand pretty quickly. It's very basic. Yeah, the internet's pretty slow. Okay, finally. So we skip this one. Skip. skip. Okay, if you can choose one item from a group of m items and a second item from a group of n items, then the total number of 2-item choices is going to be m times n, based on the fundamental counting principle. Because we can see choosing a 2-item choice, selecting a 2-item choice as a task, and that task has 2 steps. The first step, since you choose one from m, then you have m different ways to complete it. And second step, since you choose one item from the n items, you have n different ways to complete it. So based on the fundamental counting principle, we have in total m times n, that many ways to complete the whole task. We have in total m times n, that many 2-item choices. Yeah. Leave me a message on the chat if you have any question. The number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. This is called the fundamental counting principle. Yeah, we have different ways to describe fundamental counting principle. I like to describe whatever the situation as a task. I always start from identifying what task we need to accomplish, and how many steps in the task. Yeah, how many options do we have in step 1? How many options in step 2? How many options in step 3, and so on. And then we multiply all the numbers together. So that is the application of fundamental counting principle. Important thing is, multiply them. Please do not add them. There are how many ways a person can order a 2-course meal? Okay, a restaurant offers 9 appetizers, 6 main courses. In how many ways can a person order a 2-course meal? Okay, what's the task here? The task here is to order a 2-course meal. This task has 2 steps. Let's say the first step is to pick an appetizer, 9 different options. Second step is to pick a main course, 6 options. By the fundamental counting principle, multiply 9 and 6, 54. Very straightforward, right? Yeah, we spend 15 minutes on this section. A popular brand of pen is available in 14 colors. 2 writing tips. How many different choices of pens do you have with this brand? So what is our task here? Our task is to select a pen of the brand, right? Yeah, and we need to go through 2 steps. The first step, we need to decide on the color. Second step is to decide on the writing tips. So the first step, we have 14 different choices, 14 different ways to complete it, to make the option. And the second step, we have 2 different options. So fundamental counting principle, multiply 14 by 2, 28. A sales representative can take one of 4 different routes from C to E, and any one of 7 different routes from E to M. How many different routes can she take from C to M going through E? So this problem is the same with my example, right? I use ABC. Yeah, this is CEM, same thing. So the first step, we have how many routes? 4. Second step, 7. So 4 times 7, 28. An ice cream store sells 4 drinks in 4 sizes and 8 flavors. In how many ways can a customer order a drink? The task here is to order a drink, while the customer need to decide on 3 things. Step 1, decide on what type of drinks, right? Maybe orange drinks, grapefruit, lemon, yeah, something like that. So what type of drink? So that's 4 options. Second step is to choose a large, the size, large, medium, or small or tiny, small. And the third step is to flavor. And what is the first step? Maybe is like a shakes, smoothies. Well, so anyway, so based on the fundamental accounting principle, we need to go through the 3 steps in order to complete the task. Then we're going to multiply all the 3 numbers, 4 times 4 times 8, right? Yeah, what do we have? 16 times 8. 124. Yeah, let me double check. 16 times 8. 128, my bad, sorry. Yeah, 6 times 8 is 48. Yeah, that many different options. And this one, a restaurant offers the following limited lunch menu. Main courses: ham, chicken, fish. Vegetables: corn, green beans. Beverages: coffee, tea, milk, soda. Desserts: ice cream and brownies. If one item is selected from each of the 4 groups, in how many ways can a meal be ordered? Task here is to order a meal. 4 steps. Yeah, we can follow the order of the 4, go through the 4 categories. So 4 steps from top to the bottom. On your scratch paper, you want to write down the first step, main courses. I have 3 options. Write down 3. And the second step, choose the vegetables. I have 3 different options. Write down 3. Oh no, hold on. So how many vegetables do we have? 2 vegetables only, right? Yeah. So it's 2. Second step, we have 2. So even I see 3 words, but actually only 2 vegetables: corn, green beans. Yeah, be very careful. Third step, 1, 2, 3, 4. 4 beverages. The last step, desserts: 1, 2. 2 options for dessert. And multiply all the 4 numbers you wrote down on the scratch paper. Use your calculator, and you got a 48. You got a 48 ways to order the meal. Shoppers in a large shopping mall are categorized as male or female, over 30 or 30 and under, and cash or credit card shoppers. In how many ways can the shoppers be categorized? So our task here is to categorize customers, and we can go through all the given steps. Yeah, the first step, categorize as male or female, so that is 2, right? 2. Second step is to categorize the age, over 30 or no more than 30, so also 2. And the third step is to is their payment method, right? Cash or credit card, so also 2. So only after all the 3 things, we complete the task. So we have 8 different ways to categorize the customers. 8. All right. Yeah, let me know. Do we have a pretty good understanding about what is fundamental accounting principle now? Because we are going to go to 11.2 now. Yes or no? Okay, awesome. Thank you, Ashley. Thank you, Layan and Aiden. Yeah. So let's go to 11.2. Let me close this one. 11.2 is about the permutation. And what is a permutation? And in my video, I want you please relate permutation as one example only. Okay? Yeah. So let's say you have on your floor, so in your room on your floor, you have 5 different books. 5 different books. That's all the books that you have. And your task here is to randomly select 3 books from 5 books and then put them on the shelf. Let's say you just bought a small bookshelf, but the bookshelf is so small it only can fit 3 books, right? Yeah. So slot number 1, slot number 2, slot number 3. And on the floor you have 1, 2, 3, 4, 5 books. So your task here is to take to choose 3 books from the 5 different books and put them in the bookshelf. So I want you to, whenever you think about permutation, and you can relate the concept with this example. All right? Yeah. Let's firstly figure out how many different ways do we have to complete this task. Yeah. So I'm going to complete the task by following 3 steps. The first step, I choose a book and put it in slot 1. Since on the floor I have 5 different books, I have 5 different options. Okay, yeah, now we have a book here already. And the second step is to pick 1 book from the rest of 4 books on the floor. So we don't have 5 books on the floor anymore, right? We only have 4 books. So choose 1 from the 4 and put it on this slot. And the third step is to choose 1 book from the left 3 books on the floor and put it on the third slot. So since I already took 2 books, so I only have 3 options when I select the third book, right? Randomly select 1 from the 3 books. So I have 3 options. So 5 times 4 times 3, that is 60. So I have 60 different ways to complete this task. And this is a permutation. Permutation is an ordered arrangement of items. And the permutation we are talking about is the permutation of n items taken R at a time. So R is always less than or equal to n. Yeah, if you already watched the video, then you know what I'm talking about. But if you have not watched your video yet, it is still okay because it's not a very super difficult concept to understand. This is just a symbol. This is a symbol or notation. This symbol denotes the number of permutations of n items taken R at a time. Yeah, so if we change the value to 5 and 3, then we can understand it a lot easier. Yeah. So P53 basically is the total number of ways to complete a task. What task? The task is to select 3 different items from the total 5 different items and make an ordered arrangements. Yeah, for example, put on a bookshelf. So the order of the books matters, right? Yeah. So if you have the first book is a dictionary, second book is a history, third book is mathematics, would it be different from the first book is mathematics, second book is dictionary, third book is history. Even the 3 books are the same 3 books, but the order make a difference. Those 2 arrangements are counted as 2 different arrangements. Yeah, let me say that again. When you see something like that, yeah, P53, there's a number on the left by the left foot, there's a number by the right foot. That is a permutation notation. Yeah, that is a number. I'll show you how do we find a number very quick on your TI-84 calculator. Yes, TI-84 calculator continue to be useful in the new chapter. And this number this notation represents the total number of ordered arrangements of n item choose 3 at one time. The total number of order arrangements when we select 3 from 5 different items. It's like we select 3 books from the 5 books, right? And put them on the bookshelf. How do we compute the value? Yeah, this we can just use the fundamental counting principle to find the value, right? But it's not convenient. The most convenient way is to use the TI-84 calculator. Please have your calculator ready. Please have your TI-84 calculator ready. I believe you should still have that. And on the main page, enter 5. Okay, enter 5. And then look at a key. Says math, M-A-T-H. Enter that. Okay. Yeah. So firstly, turn on your calculator. You can clear everything. Yeah, enter 5. Enter the bigger number first, and then push the button math. Do you see a menu, horizontal menu on the top, across the screen? And then you go to the right. Yeah, move to the right. This key. Go to the right. Go to the right. 1, 2, 3. When it is highlighting PRB stands for probability. Okay, probability. And then you will see a menu, kind of like a drop-down menu at probability. You see 1, 2, 3, 4, 5, 6, 7, right? Yeah. Number 2, go down one time, and then the number 2 is NPR. Do you see NPR? Enter that, and it guides you back to the main page, right? And then you enter 3, and then you push enter, and make sure you have 60. Do you have 60? You should have 60 on your calculator. Do you have that? Yeah. The process, maybe your calculator might be a little bit different. Oh, thank you, Lauren. Yeah, thank you. Maybe a little bit different, but you should be able to figure it out. I believe you can. And also, in case you don't have a graphing calculator and you only have a scientific calculator, you know, scientific calculator also have the function for you to compute permutation, NPR. It doesn't matter how big the N is, how big the R is. Yeah, R is always less than or equal to N. So what if we have 5 books and then we are going to put all the 5 books on the shelf? So P55. Yeah, you can use the function P55 to find the value, or I want you to know that is the same with 5 factorial. And what is 5 factorial? Yeah, we have 5 books. We're gonna put on the bookshelf, right? 1, 2, 3, 4. Let's say you buy a bigger bookshelf, and you can put all your 5 books on the shelf. So the first step, you have 5 options. Second step, you have 4 options. Third step, you have 3 options. Fourth step, you have 2 options. And when you select a book for the last slot, 1, 2, 3, 4, 5. You only have 1 book left on the floor, right? So you have no choice. That's just one book, one book. So multiply by 1. This is 5 factorial. Yeah, this is also an important definition in this section. 5 factorial simply is 5 times 4 times 3 times 2 times 1. You see the pattern, right? And what if we have 7 factorial? That simply means 7 times 6 times 5 times 4 times 3 times 2 times 1. What about 100 factorial? 100 factorial is 100 times 99 times 98 times 97 times 96, and so on times 2 times 1. So that is the definition of factorial. Sometimes I call this as a full permutation. Full permutation means you took all the items. You make an ordered arrangement of all the items. All right, time to practice. Yeah, this is 1.2. Yeah, so skip that. Skip that. Skip that. Okay, anyone can tell me what is this equal to? Do you need a calculator for that? 0 multiplied by anything is 0, okay? We don't need a calculator for that. Okay, so this is called a 5 factorial. This is the word factorial is the product of all positive integers from 5 down through 1. By definition, okay, 0 factorial is defined as 1. So this you might want to remember, memorize. Yeah, 0 factorial equals 1. 0 factorial is not equal to 0. Let me explain why. Why 0 factorial equals 1 makes more sense. Let's say you have 0 books, 0 book, and you choose 0 book on the put on a shelf. Now how many options do you have? You have one option. Your option is nothing, doing nothing. So one option, your option is doing nothing. Okay, the number of possible permutations if R objects are taken from N items is PNR. And the formula, you're gonna figure out yourself, okay? Yeah, is this one. Yeah, I have that explained in my video. The focus of our practice today is to identify a permutation situation, and we are able to quickly to find N, find R. The number of permutations and items or P items are identical. Okay, so this is the last topic in this section, is this one. Okay, if the N items have identical items, then numerator is going to be N factorial. Denominator going to be P factorial times Q factorial. The number of permutation of N items. Yeah, the full arrangement, full ordered arrangement of N items is N factorial. However, P of them are identical and Q of them are also identical. Then we have to remove the factor. To remove that is we divide by P factorial and then divide by Q factorial. Again, I have more detailed explanation in my video. Here we focus on identify the permutation situation. There are 6 performers who will present their comedy acts this weekend at a comedy club. How many different ways are there to schedule their appearances? Something like this, arrange performers, or schedule performers. That definitely is permutation. Why is permutation? Because the keyword in the definition of permutation is order. In a permutation, order matters because the permutation is an ordered arrangement of how many items from how many items. So order matters a lot. So since the order of those performers make a difference, right? Yeah, who is the first one perform? Who is the last one perform? That's a totally different permutations, right? Different schedule. So this is a permutation. And we choose, there are 6 performance groups. How many? Okay, so this is P66, okay? P66. This is P66. Let me write it down. Because we choose 6 performers from the 6 performers and make arrangement, right? Ordered arrangement. Or this is also equal to 6 factorial. Either way, please use our calculator and help me to find out what is the value. Use a calculator and help me to find out what is the 6 factorial or P66. And you can type your answer. 720, right? Awesome. Thank you, Len. Thank you, Lauren. Very good. Perfect. And next, in an encyclopedia of language, the author presents 5 sentences that make a reasonable paragraph, regardless of their order. The sentences are listed below. You know, we don't have to really read those sentences. If you are interested, you can read them. Sometimes I don't even read them. Yeah, in how many different orders can the 5 sentences be arranged? So this is just a full permutation, P55, P55. Yeah, and to make a paragraph, right? Yeah, how many different orders? So of course the order make a difference. So this is a permutation, P55 or 5 factorial. That's gonna be 5 times 120. Okay, yeah. 5 times 4 times 3 times 1 times 2 times 1. There are 9 performers who will present their comedy acts this weekend. When you see something like that, is a permutation because the order matters. When you schedule, of course, the order is the big thing to consider. One of the performers insists on being the last stand-up comic of the evening. If this performer's request is granted, how many different ways are there to schedule the appearances? Okay, so let's see what's going on. What's the task here? 9 performers. One of the performers is on being the last stand-up. Okay, so does that mean we only need to, as a manager, we only need to make and order the arrangements for the rest 8 people, right? So this is a P88, P88 or 8 factorial. Let's use a calculator. Let's see what is 8 factorial or P88. Yeah, let me know what you got. It's a large number, 40320, right? Yeah. Awesome. Thank you, Lauren. And this problem, you need to arrange 9 of your favorite books along a small shelf. The same example is mine. How many different ways can you arrange the books, assuming that the order makes a difference to you? Okay, so 9, right? P99 or 9 factorial. Yeah, just quickly get a calculator. 9 factorial. 9 factorial gives me very large number. It's 3, 6, 28, 80, 362,880. That many different ways. Yeah, some of them might surprise you, right? Wow, that's a lot. Is a lot more than what I, thought. This question, a camp counselor and 6 campers are to be seated along a picnic bench. In how many ways can this be done if the counselor must be seated in the 5th seat and a camper who has a tendency to engage in a fight must sit to the counselor's immediate left? Okay, so that means the counselor must take the 5th seat, and the guy who likes to fight must sit to the 4th seat. Okay, so that means 2 people. We don't really have to. The 2 people is already there, right? Yeah, the counselor taking the 5th seat. The guy like to fight, take the 4th seat. Then we only have 4 people to arrange. Okay, 4 factorial, 4 times 3 times 2 times 1, 24. Oh, hold on. 6 campers. Oh, 6 campers and a counselor. Okay, so hold on. Is this going to be 5 factorial? 120. Okay, and that is a permutation. I hope we have a good understanding about permutation. Yeah, those are about the calculations, factorials. And let's do one more and then go to combination. A club with 8 members is to choose 3 officers. Oh, this is a good one. Yeah, a club with 8 members is to choose 3 officers, president, VP, and secretary treasurer. If each office is to be held by 1 person and no person can hold more than 1 office, in how many ways can those offices be filled? So our task here is to select 3 people from the 8 people and put them in the 3 positions, right? This is a permutation, just like the book example that I gave you. Yeah, select 3 people from the 8 people and then put them on a shelf, put them on the 3 different offices, right? Order matters because you are the VP, I'm the president, and Lauren is the secretary. Would it be different from Lauren is the president, I am the VP, and you are the secretary, right? So even the 3 people are the same 3 people, the order would be matter, would make a difference. So this is a permutation. So P8 3, P8 3, okay? So P8 3, so we enter 8 first. Yeah, please do the same thing with me, and then go to math, probability, NPR, and then enter 3. Yeah, P8 3 gives me 336. That many different ways. Okay, yeah. So yeah, we need to go to combination now. Let's go to combination. Combination is 11.3. Refresh. Let me go back. Assignments. So 11.3 is about the combinations. And in my video, I also only introduced 1 example. I said, if you remember the 1 example, all other combination problems would have the same pattern. If you identify the same pattern, okay, that's a combination. Let me show you what is the example that I gave in the video. Combination. The example is this task. You have on the floor, you have 1, 2, 3, 4, 5 books, right? And now you are going to travel. You are going to travel, and this is your suitcase. Your suitcase, and you are going to go to Hawaii. Yeah, you want to take 3 books with you, okay? You are choosing 3 from the 5 books and put them in a suitcase. So it's not put them in on a shelf. So you are not making an ordered arrangement. It doesn't matter the order of the 3 books in the suitcase. They are just in the suitcase. So when we talk about combination, we only concern select a subgroup. So please remember this keyword. Yeah. When you identify this task is simply just select a subgroup from the total number of the items, that is a combination. The order of the items in the subgroup does not make any difference. Okay, yeah. Which book on the top or on the bottom? No, we don't consider that. We are not very, just a bundle. All right, so how many different ways we can complete the task? What task? One more time. Our task is select 3 from the 5 books and put them in the suitcase, throw them in the suitcase. In other words, we are selecting a subgroup from the 5 books. The subgroup contains 3 books. So how many ways we can complete? How many different ways we can complete the task? This is a combination. So C is the initial combination. C53. Okay, 5, the bigger number, is the total number of the items, and 3 is the number of items in the subgroup. And how do we find the value? Yeah, we do the same thing. Yeah, please help me do this with me. and enter 5 first on a calculator, in a calculator, and then go to math. You see the menu across the screen, right? Go to the right, 1, 2, 3, to highlight probability. Yeah, and the next time we go down to number 3, NCR. NCR is a combination, right? And then enter 3. So C53 is 10. Yeah, let me see. Do you have the same value? Exactly. Thank you, Lauren. So we have 10 different ways. 10 different ways to complete the task, right? Yeah. So excuse me. Suppose the n value and the r value is the same. Combination has a lot less, is a lot less than the corresponding permutation. It makes sense because in permutation, the order makes difference, but in combination, order doesn't make a difference. That's why combination with the same n, same r has a lot less value. Yeah, so this is a 10. We remember P53 is a 60, right? But C53 is only 10. Okay, so let's practice combination. Any situation, any problem, you identify all the same pattern. Is the same pattern with the teacher's example. Select the 3 books from the 5 books and put them in the bookshelf. Yeah, we don't worry about the order. All we worry about, all we concern is to get a subgroup of 3 from the 5 items. Then that's a combination. Yeah, let's skip those calculation problem. Number 5. Okay, fill in the blank. The number of possible combination if R objects are taken from N items is a CNR. So this is about the formula. Okay, this is the formula. Yeah, about the formula, you figured out. Watch my video and figure it out. This one, the formula CNR has the same numerator as PNR, but the denominator has an extra factor. The extra factor is this one. Yeah, those are about the formulas. Combination problems involve situations in which the order of the items makes a difference. No, this is false. Permutation, order matters. Combination, order does not matter. So we should choose combination to permutation. Yeah, and the change makes a difference. Oh no. So this make a difference to does not make a difference. This one. Sorry, 42 people purchase raffle tickets. 3 winning tickets are selected at random. If first prize $1,000, second prize is $500, third prize is $100, in how many different ways can the prizes be awarded? So this is a combination problem or permutation problem. Does the order of the 3 people from the 42 people matters? Think about, do you want to get $1,000 or $500? Is that make a difference? You got $1,000, I got $500, or you got $500, I got $1,000. That make a huge difference, right? So this is a permutation problem because the order of the ticket holder selected doesn't matter. Okay, that's a permutation problem. So this is a good. When we learn more concepts, when the 2 concepts are pretty closely related, we want to put them together, compare and contrast. And let's look at this problem. Still 42 people purchase raffle tickets. 3 winning tickets are selected at random. If each prize is 500, in how many different ways can the prizes be awarded? This is a combination problem because all the 3 people same, right? They all get $500. The order really doesn't matter. We don't have a first prize, second prize, third prize. All that matters is to select a subgroup of size 3. Select a subgroup of size 3 from the total 42 people. That is a combination problem. Yeah, and all the 3 people will get $500 combination because the order does not matter. Yeah, how do we do this? Calculator, right? Yeah. You know, I know the answer is 15. Why is 15? Because C1514 is the same with the C151. Think about it. From the 15 items, you randomly select a subgroup of 14 items. Yeah, you select a subgroup with a size of 14. Is that equivalent to you select a subgroup with a size 1? Think about it. You have 15 items, right? Yeah, you take a subgroup with 14 items. Then you have 1 item left, right? Would that be the same with you select one item? You select a subgroup with 1 item from the 15 and the 14 left, right? It's the same thing. And the C151 is 15. Select 1 from 15. Yeah, or you can just use the calculator. You get the same answer anyway. And you can use your calculator to do those problems. C55, that is 1, right? Think about that. You have 5 books. You take them all and go to Hawaii. How many options do you have? 1 option. Take them all. Dump them into the suitcase, right? That's also calculation. Calculation. And this is 1. Yeah, you have 6 books and you choose 0. Now how many ways you to do the task? I don't take any book. You have 1 option, then you don't take any book. Do not take any books. That is your option. And calculation, you can do it yourself. Calculation. Okay. An election ballot asks voters to select 5 city commissioners from a group of 19 candidates. So the total number of items here is 19. In how many ways can this be done? This is to choose 5 from 19. Choose 5 from 19 to form a, what is that called? Commissioners. So this is a subgroup, right? It's a subgroup. It doesn't say the 5 people who is the president, who is the vice president. It doesn't matter. So we only concern a subgroup of 5. So this is this is a combination problem. C19 5. All right, let's use a calculator. Let's see what is a C19 5. So enter 19 first and go to math, P probability, number 3 NCR. How many people? 5. Yeah. C19 5. I got 11,628 is a lot, right? Even a combination. Yeah. This many different ways to select the commissioners. And those commissioners would be the decision makers. Those different decision makers would make different decisions. It really would affect the city, right? Yeah. Are we good? How about it's already 6:51? Let's do one more. Of 13 possible books, you plan to take 7 with you on vacation. How many different collection of 7 books can you take? Same with my problem. So C13 7. Enter 13 and then math, probability, NCR 7. And I got 1716. Yeah. So we achieved our goal for today, all right? We achieved our goal. We understood what is a fundamental counting principle. We understood what is a permutation, what is a combination. on what's the difference between permutation and combination. In permutation, order matters because all it about is ordered arrangements. But in combination, order does not matter. It's all about a subgroup. All right, this is about today. So I think you might not want to learn this yet because until you finish test 2. But we have to follow the syllabus, then we don't fall behind. Yeah, again, if you have any questions, please feel free to email me. I'll see you tomorrow, guys. Thank you for coming. We have a full group today, full class today. That's awesome. Thank you, Ashley. Thank you, Lauren. Thank you, Lane. And you guys have a good evening. Yeah, thank you, Aiden. Bye-bye.